Hello, welcome back. I'm Miss Zainab, and today we're going to be talking about hexadecimal numbers. So, we're going to be looking at what are hexadecimal numbers, what do they look like, what are they used for. Then we're going to be talking about how to convert hexadecimal numbers into binary numbers and vice versa, and then how to convert hexadecimal numbers into denary numbers. So, remember, our denary numbers are our normal numbers. So, enjoy. Okay, so these are different types of examples of hexadecimals. There are loads and loads and loads more, but I just thought I'd just show you different types of examples on this slide. So you can see with these hexadecimals, this is very different to binary. For one, it's a lot more shorter, as you can see, and that's actually one of the main reasons why people like to deal with hexadecimals more than binary, because it is much shorter. And if you look very carefully with these hexadecimals, you'll notice that we have different ranges of letters and we have different ranges of numbers, but again, the position of the number or the position of the letter is very, very important. So mostly in your GCSE, you'll be dealing with only 2 characters, but sometimes they like to throw in a bit of a curveball and use 3 characters, and I'll explain to you about how to be able to deal with those. So I've just put one in there for reference so that you know that we'll be covering that as well. Okay, so why do we need to use hexadecimals? So like I said, the reason why a lot of programmers prefer to deal with hexadecimals because they are shorter than binary. So imagine writing 100111100 when you can actually shorten that and write exactly the same number but with using hexadecimals with only using a couple of characters. So that way it will take up much less storage and it will be much more shorter to be able to write. So where are hexadecimals used? Well, actually, there's a whole host of different places that hexadecimals are used, and they're actually used in very, very different ways. So I've put up on the screen, these are the most common ones that come up in marking schemes. You don't actually have to be able to explain each concept, and many of these concepts appear in some of the other topics. So the ones that we have that come up are MAC address, memory dumps, machine code, colors in HTML, and ASCII code. So I would say all of these appear in other topics as well, so you'll be able to make the links. They're very simple. So MAC addresses are used to be able to identify different devices, and they use hexadecimal to do so. Memory dumps are used to be able to identify problems when a system crashes. Machine code is used in programming. ASCII code is linked to your keyboard. You can actually find the ASCII code on, if you just type it into Google, you'll see there's an ASCII code for each key on your keyboard, along with a binary code, along with hexadecimal code as well. Then you've got colors in HTML. So when you are writing a web page in HTML, then you'll have to use hexadecimal code to be able to identify different colors. Actually, if you look up different color palettes that you see on the internet, when you hover your cursor over different color palettes, you'll see there are different codes, and the codes will constantly change according to where your cursor is. So each color, even each shade of color, has a different hexadecimal code attached to it. So again, you'll probably see these in other topics, but this is just a brief overview. Okay, on to the interesting stuff. So basically what we want to do, we want to be able to do our conversions between hexadecimal codes and between denary and between binary. So our hexadecimal table. Now remember what we showed you before is that hexadecimal is different to binary because binary uses 1s and 0s, and hexadecimals, you can actually see straight away from this table that it actually uses 1, 2, 3, 4, 5, 6, 7, 8, 9. So it actually goes even further than that it uses A, B, C, D, E, and F. So everything in pink there is using the hexadecimal codes, and the numbers below show you what they mean. So obviously you can't have 1, 2, 3, 4, 5, 6, 7, 8, 9 and then go into 10 using 1 and 0, because that would mean something completely different. It then jumps into the alphabet. So A, B, C, D, E, F, and then it stops right there. Okay, so it stops at 15. So if we want to be able to use hexadecimal codes, we have to be able to use this table. Now, what I'll do on some of the slides is that I'll keep the A, B, C, D, E, F part on some of the slides to help you refer to it whenever we're talking about it. Okay, so Now our first one that we're going to convert is A6. So A6 is a hexadecimal code. We're going to convert this into binary first. So first thing I'm going to do is I'm going to split this hexadecimal code into two. So A being one part, 6 being another. First of all, let's start off with A. So we can see from the left-hand side, I've circled it in red. We remember that A is equal to 10. So we'll put that down as A equals 10. And then we know already that 6 is normal. 1 to 9 is just normal numbers. So 6 means 6. So then what we want to do is we want to convert these two numbers into binary codes. So let's have a look first at this one, at number 10. So we're going to convert 10 into a binary code. Now, remember, it's a very, very small number. So I don't really need to go higher than 4 bits. I can just use 8 as a maximum because the next one up would be 16, and we already know that that's too high. So we only need to use 4 bits here to be able to work out what the binary code would mean. And remember, if I'm writing in 8-bit format, I just fill in the zeros. That's all I would need to do. So it's very easy. Okay, so let's see if we can remember how to be able to convert them. These are normal numbers, and we're converting the numbers into binary. So first off is that we put the 1 on the biggest number that we can fit into 10. So in this case, this is 8. And then 10 minus 8 is equal to 2. So then that 1 fits nicely underneath the 2, and then I fill in my zeros. So I'm left with 1, 0, 1, 0. So 1, 0, 1, 0 is 10 in a 4-bit format. So remember, if I was going to turn it into an 8-bit format, what would I need to do? I just need to add my zeros to the left. I add 4 zeros. But in this case, anyway, let's stick with this. So 1, 0, 1, 0, that's perfect. Now I'm going to do the same thing with the number 6. Now remember, I wouldn't put a 1 underneath the 8 because that's too big. So I'd put a 1 on the next number down. So the 1 on the next number down in this case is the 4. So then I need to do 6, take away 4 is equal to 2. And the 1 fits nicely underneath the 2. And then I would just fill in my zeros. So then we know that 6 in binary is 0, 1, 1, 0. Okay, so these are my two numbers. Now, all I would need to do is join them together. So 1, 0, 1, 0, 0, 1, 1, 0 is equal to A6, and that's our job done. Okay, so that's the first bit. Right, next thing we're going to do is we're going to convert binary to denary. So this is one method. I will show you how to do hexadecimals directly into denary, but let's say you forget how to do that and you get stuck in the exam, you can always do it the long way and convert it into binary first and then convert binary to denary. Okay, so let's have a look at our binary number, 10 10 0110. So I'll put my table in there as I did in my last video, and I've put all the blocks in for you. So 1 2 4 8 16 32 64 1 2 8. Remember, I double it each time, and I put my numbers in there. And remember, we have to add up all the ones that have a 1 underneath it. So we have 1 to 8, we have 32, we have 4, and we have 2. All of these have 1s in them. Then, if you remember, what we need to do is just add them together. So 128 plus 32 plus 4 plus 2 is equal to 166. And it's as easy as that. So A6 is equal to 166. Done. Okay, so let's do the conversion directly now without doing it the long way. So converting hexadecimal into a denary number. So remember, denary numbers are just the normal numbers. So the normal, like, that we would use, 0, 1, 2, 3, 4, 5, 6, what we use in everyday life. Okay, so I'm going to pick a different hexadecimal number this time. So I've gone for D5, just at random. Then I have to put in positions. Now, this is what I was talking about earlier, that the position plays an important role. Now, with binary, we know it's 1, 2, 4. This one is a little bit different. Okay, with this one, it does it to the power of 16. Okay, so it's a base 16 model. So all you have to do is remember that. Okay, it's 1 and 16. That's all you have to remember. Okay, so you put your D and your 5 in there. The D goes under 16 and the 5 goes under 1. Okay, that you have to make sure that you don't get those mixed up, and you always do 1 on the right hand side and 16 on the left hand side. Okay, so let's put our A, B, C, D, E, F on the left hand side to refer to if we need it. And the first thing I'm going to do is work out what D would mean in a normal number. So if you look on the left, I've put a red circle around it. We know that D means 13. Okay, so then what I'd need to do is multiply 13 by 16. And I would multiply it by 16 because it's underneath the position of 16. So remember, if it had been like a number under there, if it had been 2, for example, if it was 2, 5, then I'd have to do 2 times 16. So it's whatever number's underneath there. Then I would do 5 times 1. So remember, I times by 1 because 1 is the position that's that the 5 is under. So I times them 2 together. So I would then add those two values up. So 13 times 16 is 208. 5 times 1 is obviously 5. And then I would add them together to get 213. And that's how to do the conversion. Really, really easy. Okay, let's try another one. Now this one is a bit of a tricky one because it says 25. Now that looks like a denary number, doesn't it? But it actually isn't a denary number at all. This is a normal hexadecimal number and it doesn't mean 25 at all. So we do the same thing. We put a 2 in, we put a 5 in, then we do 2 times 16 and then we do 5 times 1 and we add them together. So 2 times 16 is 32, 5 times 1 is 5, add them together, we get 37. So hexadecimal 25 is the denary number that means 37. Okay, so converting now a denary number into hexadecimal. So this is 37, normal 37, our normal number. So we want to convert that into hexadecimal. So we'll put the positions on the left-hand side to be able to refer to. Remember, you can write that in an exam as well to be able to help you remember, to make sure you don't make any mistakes. Now, all I'm going to do first is I'm going to divide 37 by 16. Okay, so I divide it by 16 because remember that hexadecimal uses base 16. So we do 37 divided by 16. In this case, there's 2. Okay, so 16 goes into 37 twice. I know that there's going to be a remainder, and that remainder is actually very, very important. So we put 2 underneath the position of 16, and then the remainder is what's left behind. So we know that 2 times 16 is 32, right? So we do 37 minus 32 to work out what the remainder would be, and the remainder is 5. And then we just pop that 5 underneath the 1. Easy as that. Okay, so the hexadecimal number there you can see is 25, and then the denary number is 37. Easy peasy. Okay, so remember that this 25 is actually a hexadecimal. It's not a denary number. The denary number is 37. So that can get thrown into an exam to kind of throw you off. So let's do a larger number. So we have 157 denary number. And let's put our positions in. So we've got 16 and 1. We divide 157 divided by 16. Remember, we do it by 16 because it's a base 16. We're trying to work out what goes underneath there. Okay, so 16 goes into 157 9 times. So we put the 9 under the 16. We work out what the remainder is. So it's easy to work it out. You do 16 times 9. And then you take that away from 157. So it's 144. So 157 minus 144. So remember, 144 is what 16 times 9 is, okay? So 157 minus 144 is 13. Now, we can't put 13. We know we can't write the number 13. So remember, that's what we have those blocks on the left-hand side. So what does 13 mean? 13 is a D. So I would put D in. So it would be 9D. Easy peasy. Thank you so much for watching. I hope you enjoyed it and I hope you learned something too. So we covered what are hexadecimal numbers, where are they used, and we looked at converting hexadecimal numbers between binary numbers and converting them into denary numbers and vice versa too. So I hope you enjoyed it and I'll see you on the next video.